In this next problem, we're going to transform an equation that is in polar form to an equation in rectangular form. The equation that we have is r equals 2 cosine of theta. To transfer this equation into polar form, what I'm going to do is multiply both sides of the equation by r. The expression on the left becomes r squared, and on the right I end up with 2r cosine of theta. Now the reason for doing that, that is multiplying both sides by r, is because now on the left, r squared, you recall, is equal to x squared plus y squared. So I can write x squared plus y squared on the left. And on the right-hand side, you'll notice that I have r cosine of theta. Recall, r cosine of theta is x. So on the right-hand side, I get 2x. Now I'm going to rewrite this in a form that is recognizable. Subtract 2x from both sides, and we obtain x squared minus 2x plus y squared equals 0. I'm going to complete the square in the variable x. Recall how to do that. You take half the coefficient on the linear term, so half of negative 2 is negative 1, and then square that result. Negative 1 squared is 1, and then plus y squared. Remember, since I added 1 to the left-hand side of the equation, I also must add 1 to the right-hand side. Now, x squared minus 2x plus 1 is going to factor to x minus 1 quantity squared. Then plus y squared equals 1. You should recognize that this is the equation of a circle because it's of the form x minus h quantity squared plus y minus k quantity squared equals r squared. So the center of this circle is the point. H is 1, k is 0, so the center is 1, 0. The radius is going to be equal to 1. So to graph this equation, I'm going to plot a point at 1, 0, then plot points 1 unit to the right, left, up, and down from the center, and then draw in my circle. If we do that using a polar grid, there's my center at 1, 0, 1 unit right, 1 unit up, 1 unit left, 1 unit down. We have the graph of the circle.